Hello everyone, this is Guillermo speaking. On the last video we were setting up our input listener component, and if I click on play, we now were dealing with the horizontal and vertical axis, and let ORK Framework have access to this information for later purposes. But also I implemented or added more information, so I have now the stick direction using my gamepad. So if you remember that we were talking about having the character to walk or be walking up till we get the stick at 1 or less or close to 1. So you can see we had should jog and otherwise still walking. To give the mechanic similar to Dark Souls or Bloodborne, the games made by From Software. So what I did, let's revisit the input listener script. In the first place, I already had the look action that we created in the input actions. In this case it's not static because I don't want this to be used in ORK Framework at all. We are going to implement later on in the next video the Cinemachine third-person camera, so this is just going to be used by that system. Then in the on-enable, of course, I enable this look with the performance cancel. If you remember, also we had two methods. I just clean it up and just using one in this case on movement, and this one is going to handle both, where the action is performed and when the action is cancelled. So it returns whatever vector is passing through, and if it's cancelled it will set to 0. I hope so. That always works like that. And same for the look action. So I have a method that is listening for the context and reading the value from the gamepad. In this case, the right stick. Okay. We still have our Machinorg functions, static functions. I just commented out the debug logs because we don't want it anymore. We proved that it's being printed by ORK Framework properly. And in the GUI, on the GUI function, I just added this information that we saw on the screen, just getting the horizontal axis and print it out. Okay, the script also as well is going to be available for patrons, and thank you for your support as always. So let's talk about now the character movement. Alright, so let's minimize Visual Studio, and what we want to do is to, since we have the input manager, the only responsibility that this component should be is to emit whatever input the human player is trying to perform using the gamepad or the keyboard and mouse. And that's the only responsibility. So this component will emit this information, and other components in the scene can listen to those changes without having a reference to this component. That's the idea always when having design patterns implemented in your game. So what we are going to use is the same approach I did in the Lightning Returns series, where we have events made out of scriptable objects that can be invoked from the input listener component, and having the player register to this event scriptable object and listen to the changes. In that way, both are just referencing one single object outside of scope of each component, so there is no binding between components in this case. Okay, so what I find as well in Google a little bit is a open source library. I created one library one or scripts in the Lightning Returns series, but this one is more complete, I will say. So let's take a look. So these guys, Hidden Engineering, had this library System Core. I believe these guys are the ones that also have some asset store products like the Steamworks, I believe, and they made a full implementation of this concept of having event driven by scriptable objects. And here is the documentation on how to implement those, which is more complete than the one that I started in the previous series. So what I did is what already added this library into the project. Now what I can do is, for example, I created this Unity Events folder and right click, create. We have System Core, and then here Events, Simple Events, and then I have this Vector2 type of event. So let's create that, and let's call this one onMove event, right? So we have already our event, scriptable object event. So if I were to go to the player now, I could add a listener for this event. So let's click Vector2 game event listener. It's asking me for which event to listen to, so let's just drag this one here, and then we need to implement the code to react for the changes done in this event. Okay, so for that, in the first place, we also need to raise the event on this scriptable object from our script. So let's go to the script and make some changes here. So we want to subscribe to the event, or not subscribe but invoke it. So I will type serialize field, is going to be private, and it's going to be of Vector2 Unity event. It was game event. Let's add the using statement, and let's call this one onMove. Let's keep same naming convention, so onMove event. Simple as that. So what we want to do here is go below where we have a movement. We still need this to be raised by ORK Framework. So what we can do here, add a line. We need to check whether this event is null. So we have a simple keyword that used the question mark here. This is the same as doing is not null. So let's put question mark dot, and let's invoke. Now we have invoke and invoke simple. This is from the header library. So invoke will accept also the who's sending this event, and invoke simple is just going to take whatever type we are passing. So we are going to use invoke simple, and we pass, of course, we can pass the whole context or the movement. Both are Vector2. Alright, so let's save the changes and go back to the to Unity, let it compile, and if we click now in Input Manager, now we have this onMove event visible, so we can just drag this here, and now we can raise the event and the player will listen to it, but still need to write the code here. Okay, so let's go to our scripts folder. We have gameplay behaviors, and let's create here a folder, and let's call it characters. Let me spell it, characters. And inside the characters folder, let's create a new script, and let's call this one character movement, and let it Unity compile and reload. Select player and drag the component there you like it better. So let's then move it up and open up the script once again. So what we want here to do is in the first place create a public function or method to listen or to bind to the event listeners. So let's call it public on movement, and it's going to expect a vector2 input movement. This will allow us to bind this function in the event listener Unity event. So if we were to click here, now we can drag the character movement script and into the runtime slot, and then select from here character movement, and we have this on movement. Okay, that's all we need to do, and it's perfectly fine because all these components are living or residing in the same game object. So it's perfectly fine to have this reference, cross-reference. Okay, so let's go back to the character movement, and now we need a variable to store the input that we are receiving here. So let's create a serialized field. So private vector to move direction. We can copy the name, the variable, and put it here, and it will be equal to input movement. Come on, input movement. There we go. Now to actually move the character, remember that we talk about it and we are going to use root motion, but just to showcase the movement right now, we are going to use the standard or traditional method to use transform position to move the transform of the game object. Okay, so let's go here and let's enable the update method. So private void update of the mono behavior, and in here we want to then move the position of the transform component of the game object towards the move direction that we are receiving here. Something like transform position plus equal to be incremental. Then we pass here our move, sorry, not the move, this direct move direction, so we need to actually incrementally as well. So let's create here a vector tree. Move direction is going to be to the vector tree forward. Forward is a short for the Z axis in 3D world, and we need to multiply this one for our move direction. In this case is a vector2, but we pass the Y in this case, and then we add the vector 3 right, which is the horizontal plane, times the move direction X, and this is actually the move direction that we want to pass here. Then of course, traditionally we will have to store some sort of speed for the walk speed, run speed, sprint speed, but I'm just going to hard code this value here, so 5, and then we multiply this speed by time, delta time. So let's go back to Unity, let the script compile. So back in the editor, we have now in the character movement script this move direction variable, which is now we can see the input that we are receiving. So currently we don't have any mesh here to showcase this, so let me just make this one visible. And if I go to the game view again, let me go back here. We are talking about the forward direction. This is the vertical axis. In 2D world, that will be the Y, and then we have the X axis, the horizontal axis. Okay, when we talk about in 2D world, but in 3D and the Y is up, so don't get confused about that. So we are moving forward and horizontally, so left, right. Okay, so if we were to click on play now, I'm using the keyboard first, and we move forward, backwards, right and left. Okay, and diagonally as well. Okay, and now with the gamepad, same thing should be. So we have movement, and you can see that the transform is always facing the forward direction. So let's work with the rotation now. Let's stop playing and let's go back to the script. So our goal is to create a sort of adventure third-person movement, and for that to reach this goal we need to store or to have the camera transform. So let's create a serialized field and let's call it private transform camera transform, and we can cache this component in the awake function. So let's camera transform equal camera.main.transform. Alright, in the update method we are going to retrieve this information. So let's create below the update method a new function, private void handle rotation, and what we want to have is an offset of the direction of the camera. So vector 3 rotation offset. This is going to be equal to our transform, so transform camera transform dot transform direction, and what this is expecting is a new vector 3 direction. Okay, we have another parameter that we can just pass a broken vector 3 into the 3 axis, but we can here just reuse the move direction we have previously, but again it's expecting to be vector 3, so we could pass new vector 3, and here we set the move direction horizontal, 0 on the Y, and move direction y, which is the forward or the vertical axis. Okay. After having the rotation offset this, we make sure that always the y is going to be 0. Remember that in 3D world this is the up, so we want this to be always 0. And then we need a reference to our model, the prefab, or the model that we are using. In this case we were using this pivot to represent the player, but let me just unhide the mesh of the character. Okay. And here in the character movement component, what is it, down below, we now need a reference to this mesh object. Okay, so let's create that, and let's go here again, serialize field, private. We want the transform of this mesh object, so transform, let's call it model transform. And I'm not catching that one here on purpose to let if you had game designers to deal with it and play with prototyping other things. So let's here call this model transform, and then we want the forward direction of this transform to be a new vector tree, and we want to lerp the forward direction of this transform towards its own forward with the rotation offset that we created before, and we need to pass the time of the lerp of the linear position, time dot delta time. And here we need to also have a variable how much we want, or the speed of this rotation, right? So let's go up, and we have this serialized field as well, and let's call it private float rotation speed, and we can initialize this one like what, 300 for example, and let's put it down below. So that's all we need to handle the rotation. We need, of course, this function to be called somewhere here in the update method, preferably before we set the move direction, like so. So let's go back to Unity and let the script compile. And now in our character movement we need to set the model as I mentioned before. So let's click here the mesh. The camera will be set at runtime, but we could select it right now, but I will leave it like that. Just make sure that your main camera had the tag main camera. Okay, and let's play. Control P. So again, I'm using the gamepad. We got the movement, and you can see the character is rotating. As it should. And if I just tilt a little bit the gamepad, you see that we have this walk speed. Okay, so let's get out of play mode, and the next step is to start building. What I'm going to build is the third person camera using Cinemachine. I'm going to cover that in the next video. So thank you for watching once again and supporting the channel. See you in the next one.